Welcome to the Absolute Beginner's Guide to Python. This video is suitable for anyone who's never programmed and is aimed at students and people who just want to learn the very basics of Python. In order to follow along with these guides, you will need to have Python installed onto your computer. If you haven't got Python installed, what you can do is, if you're using Windows, go to the Start button and then go to the Windows Store. So it's usually highlighted there, as so, and then we're going to search for Python, and I believe the latest version is Python 3.13, and you can just click Get. When Python is installed, you can close the Windows Store and go to your Start button and type Python, and what we can do, you can see there's this idle Python app, and that's the app that we're going to be used for all our scripts whilst learning Python. You can of course create a desktop shortcut, type idle, and when the icon comes up, right click, and you can either pin to your taskbar or you can pin to your Start button, or you can just add a shortcut to your desktop. Now we have Python open, let's run our first Python program. What we're going to start with is the Hello World program, which is a rite of passage for all programmers when they're learning a programming language for the first time. To do this, all you have to do is type print, open a bracket, put the words Hello World in quotes, and then close the bracket. And if you press return, you'll see the words Hello World appears. So let's have a bit of background to Python. Now Python is what is known as an interpreted language, and what that means is, if you think of programming languages from the past such as C++, Java, C#, they're what's called as compiled languages. So you write the code, you run a compiler that compiles that code into machine readable format that the computer can run. Python, on the other hand, is an interpreted language, and an interpreted language actually runs the code as you run the program, so you don't have to compile it first. Now for compiled languages, the upside are that you see any errors at the compilation time, so any sort of programmatical errors are spotted straight away because the compiler will tell you there's an error, and compiled programs generally run faster than interpreted programs. However, the interpreted programs make it easy to get started. You don't have to worry about the compilation stage, but as mentioned before, if you make a mistake, then you're not going to find out until you try and run the code that there is a mistake. Now Python is used in all sorts of areas. It's used in data sciences, AI, web development, general programming, on Linux, on Windows. It is everywhere, and it is one of the most popular programming languages because anyone can do it. Alright, so let's start with a tutorial on variables and data types within Python. Think of variables as label boxes where you can store different kinds of information. In Python, you can create a variable by giving it a name and assigning a value to it. Now previously we ran a command which just said hello world, but it would be more interesting if we could make it display different things. So what I'm going to do is I'm going to open up a new file, and in that file I'm going to create a variable, and that variable is going to be called my name, and I'm going to set that to Gary, and then I'm going to type print my name is my name. Now what we can do is we can run that. You have to save it first, so we're going to save it. I'm going to call it my name is. We're going to save it like that, and if we go back to this window here, you can see it prints my name is Gary. Now a variable can contain letters, numbers and underscores, so I could have called my variable my underscore name. I could call my variable my name 123 and it would still work. What I can't do is start my variable with a number. That is wrong, and that will cause an error, as I'll show you here. You see there it says invalid decimal literal, so you can see that is the wrong thing to do. Now variables can be uppercase or lowercase, so I can set my name to be my name like that, and that will still work, as you can see there. And if I flick back to the window, I could actually say we'll call it Gary 2, and if I type that there and run the command, you can see both of them are displayed, and they've both got different values because they've got different cases. So that's very important when we talk about variables. Now there are different types of variable, and the type is defined at the point of assignment. So in this case, my name equals Gary, because it is between quote marks, it makes it something called a string. Now a string can contain any number of characters, it can have numbers, special characters, anything you want in it, and basically it stores text, and that's what a string stores. My age equals 50. Now this is called an integer. Now an integer stores whole numbers, so you can think it can store negative numbers or positive numbers, but it just stores whole numbers. The next data type we're going to look at is real numbers or floating point numbers. So you could say pi equals 3.14, and that's what's known as a floating point or a real number. And the final data type we're going to talk about today is called a boolean. And you basically say, is it hot? And a boolean can be true or false. So let's print some of these out to make sure that they work. So we'll start off with just my name at this moment in time. We'll save it and we'll do run module. And you can see I've made a mistake there, because true or false actually has to be capital T, and you can see the syntax changes colour when I set it to the correct thing. So it can be true or it can be false. So we'll run that again now that I've fixed the issue, and you can see what happens if you make a mistake. And you see my name is Gary has been displayed. If I go back to the window and I type print, what do you think will happen when you run that command now? You might think it's going to say my age is 50, but you'd be wrong. What actually is going to happen is it's going to display an error. And the reason it displays an error is because the print statement is expecting everything to be a string, but my age isn't a string. And you can see it says type error can only concatenate str, which means string, not int. So if I go back to here, what I can do is something called a cast. And what a cast does is it turns one variable type into another. So if I type str my age like that, and now I run the module, you can see my name is Gary, my age is 50. So let's try it with pi. What do you think will happen this time? If you guessed that would error, then you'd be correct, because in this time, actually I've got to spelling mistake there. As I said before, the case is very sensitive, so you have to make sure it's the correct one. But if I run it, it's still going to error, and the reason is it says can only concatenate str, not float. So as you can see, this is a floating point number. So all we have to do is the same we did before, put str around it, and run the module. And you can see that displays OK. And finally we can do the same for is it hot. What do you think? Do you think it will work? No, it won't, because is it hot is a boolean, not a string, so the rules remain the same. The print statement can only display strings. So we just do the same again, and you can see all our variables are now displayed in the window. Right, so the next subject area is going to be called sequence selection and iteration. So we're going to start off with a new file, and we're going to save it, and we're going to save it as sequence.py. Now what do we mean by sequence? Now a sequence is essentially just the order of how things run in your program. So if I, for instance, put print hello world, and I say my age equals 50, and then I say print my age. What we mean by sequence is it's going to run each statement line by line, and so it's going to go through each of these statements line by line as shown. And so if I run the module and go back to my shell, you can see hello world is printed, then my age is 50, and it ran through this command first, this command second, and this command third. So that is fairly straightforward. So let's talk about selection. All our programs thus far have just followed a linear flow where I've set a variable and then I've printed the value of that variable. But sometimes you want to do something if one condition is true and something else if the condition isn't true. For instance, I'm going to create a variable called my age equals, and I'm going to set it to 50. And then what I'm going to say is the UK voting age is 18 years old. So I'm going to say if my age is greater or equal to 18, and you have to put a colon, and then we do print, and we type you are eligible to vote. Now what do you think will happen when I run this command? If you guess that it will print you are eligible to vote, then you would be correct. So if I set it to 18, it should still say you are eligible to vote, because we've said greater or equal to 18. But if I set it to 17, it shouldn't display anything at all, which it doesn't. Now this might not be the perfect scenario. You might want to say if you are not eligible to vote, then you should say you are not eligible to vote. So what we can do is we can use the else statement. So we type else like that, like that. Now it should say you are not eligible to vote because I'm 17 years old. And it does. You are not eligible to vote. So we can mess around with these values. So I can do 5. And I can do 25. And you can see that works. So using a conditional statement of if and if else, you can say if one thing, do this, if something else, do this. Sometimes you will want to do multiple conditions. As an example, what we're going to do is we're going to close this and we're going to create a new file and we're going to save it as selection2. And we're going to say my score equals 70. Now the score in this case relates to an exam mark. And what we're going to say is if the person gets more than 80%, they get an A. If they get more than 60%, they get a B. And if they get more than 50%, they get a C. Something along those lines. So what we could do is we could say if my score is greater or equal to 80, print, well done, you got an A. And we could say else, and we could do another if here, my score is greater, I think I said 60, print, well done, you got a B. And we could say if my score is greater than 50, print well done, you got a C. And that would work well enough. You can see I got a B, and if I go back to here, we'll do 85. You got an A, and if we do a 55 like that, you got a C. Now the problem with this isn't very efficient. So imagine you had a dozen of these, your code would continue indenting all the way down like this. So there's a better way of writing this code. And what we can use is something called an elif. So we'll take all that out and we'll type elif my score is greater equal to 60, and then elif and you can see that's a lot easier to read, because although elif is a shortened word, what it actually means is else if. So what we're saying is if my score is greater or equal to 80, print well done, you've got an A. Else if my score is greater than 60, well done, you've got a B. And else if my score is greater or equal to 50, well done, you've got a C. So if I run this again, well done, you've got a C, and we'll make that 65. Well done, you've got a B, and then we'll say 85. Well done, you got an A. And the good thing about this is we can also now say else for anything else. Unlucky, you failed. So this should still say you got an A, but if we change this to a 25, you can see it now says unlucky, you failed. So the final area of sequence selection and iteration is of course iteration. So we're going to create a new file and we're going to save it and we're going to call it iteration. Now there's two ways to iterate, and what we mean by iteration is doing the same thing over and over and over until a certain condition is met. So sometimes you have something called a fixed iteration. So if I type for I in range 10 and then we do print, and we have to put the I in str because I is an integer, what do you think it will do? Well, let's run it and find out. you can see it displays the numbers 0, 1, 2, 3 all the way up to 9. Now let's break this down into smaller chunks. So what we mean by for I in range 10 is start I at 0 and keep going round and printing until you've done it 10 times. And it starts at the number 0, which is why it does 0 to 9. So if you wanted to type the numbers 1 to 10, then what you could do is put a +1 in there, and you can see it now does the numbers 1 through 10. Now what if you want to print just the even numbers? So this will combine the iteration and the selection tutorials together. So we know that this is going to run 10 times, and we want to do it until, and we want to find all the even numbers between 1 and 10. So what we're going to do is we're going to say if I plus 1, and we're going to use the percentage, and we'll come to this in a later tutorial, but what it means is there a remainder when you divide it by another number? And we're going to do it by 2. And what we're going to do is we're going to put all this in brackets, and we're going to say equal to 0, and note the double equals, that's important, we'll come to that later on, and we're going to close that off, and we're going to put a colon there, and then we can do this. So what we're saying here is if I plus 1, because we know I starts off with 0, so I plus 1, the first time round it will be 1. If you divide 1 by 2 and there's no remainder, then it's going to print it. So the first time round, when you've got 1, 1 divided by 2 doesn't work, so it's not going to print it. Then it's 2 divided 2 is 1, but remainder is 0, and that's important, the remainder. If there's no remainder, it's going to print it. So we're going to do 3 divided 2 is actually 1.5, so it's 1 with a remainder of 1. So that's not going to print it because the remainder isn't 0. And 4, so 4 divided 2 is 2, and there's no remainder, so it should print it, and so on. So if we run this code now, you can see I've got a mistake here. Don't need all these brackets like this. We're just going to put the bracket around the I plus 1 like this. You can see it says 2, 4, 6, 8, 10. So you saw there I had problems with my brackets, and we'll come on to that at a later point. This is to do with the maths equations, but essentially what we want to do there is do the I plus 1 first, and then divide it by 2, and then compare it against the thing we want to compare against, which is why having too many brackets didn't work. So there is another type of loop, and this is called a while loop. So we could write the same code that we had there, and so this time let's set j equal to 1, and we can say while j is smaller or equal to 10, put the colon at the end, and we're going to do the same thing again. If I plus 1 mod 2 equals 0, print str I j plus 1, and that should be a j as well. But this time we're going to print the odd numbers. So is not equal to 0. So if there is a remainder, we're going to print it. So j equals 1 while j is smaller than 10. And we don't need to say j plus 1 because j starts off at 1. And then we're going to print it. So what this is going to do, the first time round, j is going to be 1. So j is smaller than 10, yes it is. So it's going to go into here. If 1 divide 2 has a remainder, which it will, it was going to print j. And we don't want to do j plus 1, we just want to print j, don't we? And the second time round is going to be 2. So if 2 is smaller than 10, yes it is. If 2 divide 2 has a remainder, it doesn't have a remainder, it's not going to print it. Next time, 3 smaller than 10, so 3 divide 2 has a remainder, so it's going to print it. So now if we run both these commands together, one of these statements is going to print all the even numbers between 1 and 10, and one of them is going to print all the odd numbers between 1 and 10. And that should be a not equals. You can see that if you make mistakes, it tells you in the correct syntax. And you see I've got a big error there. And what do you think that error is? Control C closes the program, by the way. And the error is this. What I said before is next time round is it smaller than 10, but we never actually increased the value of j. So what that means is it's going round, j is 1, it's smaller than 10, print it because it hasn't got a remainder, go round again, j is still 1. So what we actually need to do is j equals j plus 1, like this. And that will make j go up by 1 number each time. And the big mistake I made there is that I put it in this if. So it actually has to be here. So while j is smaller or equal to 10, if j mod 2 is not equal to 0, print j and then increment j plus 1. So the very first time we go through, j is going to equal 1. So is j smaller than 10? Yes it is. Is j divide 2, does it leave a remainder? Yes it does, it's going to print j. And then regardless of the if, it's going to increment j by 1. So j will now equal 2. So is j smaller or equal to 10? Yes it is. If you divide j by 2, does it have a remainder? No it doesn't. So it's not going to print, but it is going to increment that by 1. So now 3. Is 3 smaller than 10? Yes it is. If 3 divide 2 leaves a remainder, which it does, it's going to print 3. So what we're going to end up with is 2 lists printed out. The first list is going to print all the even numbers in this for loop here, and this one's going to print all the odd numbers. And you can see that here, 2, 4, 6, 8, 10, 1, 3, 5, 7, 9. So to summarize everything we've learned in this section, sequence is about the order that statements run. Selection is about determining which route a program goes down. So if this, do this. And iteration is how many times a piece of code runs. So in a for loop, it's a fixed iteration of so many times, whereas a while loop is until something occurs. That is the end of part 1. Please stay tuned for the second part of A Beginner's Guide to Python coming shortly.